Hi, everyone. My name is Anna Grabek. I am presenting here on behalf of my other co-researchers, Sylvia and Carolyn. We're all from MITRE. And the topic of our research was market segmentation of state broadband delivery approaches. Now I'm going to have to move kind of quickly through the material, but please, post questions in the chat and I can try and respond after, or I'll also leave my email for contact. But up front, I'd like to start with a quick anchoring of why broadband and its delivery, specifically at the state level, is worthy of study. So with respect to the first part of that question, really simply, we care to study broadband delivery simply because broadband is a critical infrastructure. And also in a lot of ways, broadband access and adoption are almost becoming an assumption in our society, right? We see that with the first statistic here, where it was assumed in 2020 that school children could access fast internet from their homes and also kind of have the digital fluency to understand how to access lessons. And then again, with the second statistic, we also see that we're now kind of as a society assuming someone with just a high school degree has acquired digital fluency somewhere along the way. But with the third statistic, right, we realize that there's a problem here because these assumptions of broadband access and adoption just aren't necessarily going to be correct. Beyond just the group listed here, there are many segments of the US population that for one reason or another don't have broadband access or sort of the digital skills that come with using broadband. Now, why is it that we should care specifically about broadband delivery at the state level? Well, that is because of the Infrastructure Investment and Jobs Act of 2021. Now, if you're not familiar with it, it was actually called a once in a generation investment in infrastructure in the White House release. And specifically, it will make over 100 million available to states to improve their broadband delivery. Now, a really important point here is that it is going to be the states that will have creative control when it comes to investment allocated decisions, which means that the impact of the IIJA, as I'm going to call it from here on out, since it's much easier, in improving broadband is really going to come down to the decisions that the states end up making, which means that by taking a look at how states conduct their broadband delivery now, we can perhaps start to understand the potential challenges and even opportunities, if you will, as the IIJA funding is put to work. And then, of course, in doing so, what's really important for this talk especially is that we can also perhaps start to anticipate and mitigate any challenges to ensuring the IIJA is maximally impactful in setting us up for next-G technologies. Now, one of the biggest challenges to actually understanding how states approach broadband delivery is that there's really no single way that states do this. For example, some states might have a single centralized broadband office. Some states might have a few different agencies that tackle perhaps different aspects of broadband. And then some states actually are going to have both and some will have neither. It's really kind of a great example of US federalism. And then, of course, as with any model building, there's this second point here of what is the scope and level of detail that's appropriate? Like, do we want to try to include every aspect of broadband delivery, like results from broadband speed tests at the county or even census block level? Or are we more concerned with broader ideas of governance and then what would be the trade-offs between those two models? And then lastly, how do we or can we even account for the influence of unobservable factors? For example, just using publicly available data, we might be able to see that a state has a centralized broadband office, but of course we don't know how many people actually work in that office or the scale of that amount. It could be 20 people, or as we came to find out, it could actually just be 2 people. So 2 states might each have a broadband office, but they actually perform very differently, and that's not evident just in the data that we have publicly available. Now we can take a look at the methodology that we use to approach and sort of mitigate some of these challenges. So from our title, we performed a market segmentation. So if you're not familiar with what this means, it's pretty simply just a process typically used in a business context to categorize a target population into informative groupings. So for example, a business might like to understand the types of customers that exist in a market so that they can more easily cater to and advertise to those customers. Now, in this context, we're treating the 50 states as our market, but we're not trying to market or advertise to these states, obviously. We're just trying to understand the broadband delivery profiles that exist so we can begin to build an understanding of the challenges and opportunities arising with the IIJA funding. Now, for our data set, we decided to focus on data points that describe primarily governance of broadband delivery at the state level. So rather than focusing on broadband performance and average county speeds, like I mentioned, we could do in the introduction, we approached the segmentation asking the question, how can we characterize more state level administration, administrative structures, planning and processes that pertain to broadband. And we did this because, A, it was a nice tight scope, but also because we thought this was more directly, would better directly correspond to how states will handle the IIJA funding. So for our data set, we aggregated features that correspond to, basically three foundational aspects of broadband delivery: administration, strategy, and execution. And then the actual data points we use are described here, but they envelop like the type of administrative offices or agencies that exist, whether official strategies and goals have been defined and how recent those have been defined. And also what are some of the state level actions like conducting mapping, passing broadband laws, and setting up broadband funds, for example. Now, the general process that we use to turn this data set into a market segmentation is shown here. And I say general because we actually developed a few different market segmentations. This was done both in the interest of being exploratory. This is, kind of an exploratory research project, but also because each algorithm represents a different point on the sort of complexity, if you want to think of the complexity versus explainability scale, right? So for example, one of the algorithms we used was very sort of transparent, while some of the others were more complex in their approach, but also could handle complexities in the data set, like conditional dependence between features better. But the general approach is shown here. We first, convert all of the numeric data in our set to binary data values. So for example, the data point number of laws, that could be turned into a binary feature, that describes whether a state has over or under the median state of broadband laws for all states in the set. We then took this binary feature set, which for most algorithms had 12 to 15 features, and then performed a type of dimensionality reduction so that clustering and then deriving those final segmentations was more tractable. We only had 50 observations, right? Only 50 states. So driving that feature set down from 12 to 15 to a much smaller space was desirable, and also arguably helped make our results more interpretable. And then we can take a real quick look at the dimensionality reduction techniques that we use. The first was based on the a priori algorithm, which, if you're not aware, it's a type of association analysis that identifies features in a data set that tend to occur together. So for example, in this data set, it might find that states that have official plans also tend to have official goals, right? That would kind of make sense. Now, it conveys the associations it finds by ways of rules, which really just state the conditional probability of a set of features called here the consequent set being present given that a set of features called the antecedent set were also present. Now, for our algorithm, we were interested in reducing the data set to just 3 dimensions that could roughly describe the state's broadband programs with respect to those 3 foundational broadband delivery dimensions I mentioned in our data set slide. So administration, strategy, and execution. So we chose 3 leading indicators: presence of a central broadband office, presence of a plan, and presence of mapping, and then use the a priori to find the strongest consequence sets when each of those features was antecedent. This also enabled us to mitigate some of the effects of unobservable factors that I talked about, like what it means for a state to have a broadband office, because the amount of staff can vary wildly, like I said, is with using this association analysis with the leading indicators. Now we've folded more surrounding information into that leading indicator data point. We then use the second algorithm, linear regression, in a similar manner for a different run of the market segmentation. Only here we directly predicted how likely a state was to have one of the leading indicators based on the other features in the set. We use the common linear regression algorithm where you seek to minimize the mean squared error of your predicted points versus your actual data points. Now, a note here is, as I've already said, that this basically reduces down to just 3 dimensions with the roughly described administration, execution, and strategy. So now that we've taken our data set, we've created those 3 kind of scores. We used k-means clustering to actually derive our final segmentations. So if you're not aware of k-means clustering, it's a pretty straightforward algorithm. Basically, you do need to first assume that each sample belongs to one of n categories, and there are different methods for finding out what n should be. We use the ELPA method. But then you randomly initialize n centroids, which are just a point in your feature space. You then assign each sample to one of the n clusters using a distance metric, usually Euclidean distance. So you assign the samples based on the centroid that is closest to them, and then you recalculate the centroids based on the mean of the locations in the feature space of all of their assigned members. And then you repeat this process as shown here until there is convergence, meaning the centroids and their member assignments don't change during these update steps. And then your output, if you're in a three-dimensional space like we were, would be something like we show here, where now each of your states, each of these data points here have been assigned to a cluster, and that's shown by the colors. Now, for one of our segmentation models, we actually were able to skip both the binary value coding and the dimensionality reduction steps. And we just clustered on our raw data set. Now, this was possible because we used something called Gowers distance. This is a metric that allows you to measure the distance between mixed types of data, like numeric and categorical, or equivalently numeric and binary. So, here, other than just using Gowers distance as your distance metric, you now can really follow a similar process to k-means, right? It looks pretty close. One of the only real differences here is that we use medioids. So basically each centroid is now actually the most central sample in the current cluster as calculated using the Gowers distance. And at the end, you again get all of your samples assigned to a cluster as shown here. Now, of course, we had a feature set that was much larger than 3 dimensions for this run. So this plot does not actually show that. You'd have to kind of extend this in your head to 8 or 9 dimensions. But the point here is that whether we use k-means or k-medioids with Gowers distance, we still got an assignment in our feature space for each of our samples to some cluster. Okay, now I can finally get to the exciting part, which is the results. So from a really high level perspective, we found that there were basically 4 salient broadband delivery profiles that emerged across our segmentations. The first, which we color coded as red, were states that generally had low evidence of activity or capacity along all of the foundational dimensions of broadband delivery included in our data set. Our next profile was the opposite. States here in this green category typically had high evidence of activity and capacity along all dimensions. And then the next 2 profiles, they're a little more complex. In the blue category, these states tended to have low evidence of activity in just the administrative sense with kind of middling scores for strategy and execution. And then the second, the purple one, had low evidence of strategy activity, but then middling for execution and administration. Now, I think it's worth pointing out here 2 things. One, that we didn't observe a profile for states that had just primarily low activity in the execution dimension. So if you did have a low execution activity in the data set, then you tended to also have a low administrative activity and also low strategic activity, putting you in that red category. So low execution did not happen in isolation. A second point is that if you had a high score for one dimension, you also had a high score for the other 2. So there's no profile, for instance, with just a high administrative activity or just a high strategic activity. Now here we can see the actual breakdowns of the percentage of states assigned to each profile and our algorithms. In the interest of time, I will move quickly through these, but I think the takeaway is that most segmentations assigned the highest amount of states to the green category, except for the algorithm using linear regression. And then the most algorithms like this assigned the lowest proportion of states to the red category. That's the one that had low activity in all dimensions, except for the mixed clustering algorithm shown in the bottom right. Now these percentages, they indicate that the algorithms found the same profiles in roughly similar ratios in their segmentations, but of course they don't indicate whether algorithms agreed on which states belong to each segment. Here though, when we compare, we see that there was actually, shown here on the far right, there actually was quite a lot of agreement across the 4 models. So here we can see that 39 states, 78% of the total states were assigned to the same segment in 3 or more models, with actually 21 states being assigned to the same segment in all 4 models. And then there were 11 states shown over here that the segmentation algorithms couldn't quite agree on With 6 of those states, actually, they were assigned to 3 or more segments across the models. But if we look more closely at the proportions of the state assignments that were agreed upon in 3 out of 4 algorithms, that's here on the left, or 4 out of 4 algorithms on the right, we see that again, the largest proportion of states, 45 to 48%, were assigned to the green kind of high activity segment, and then the smallest proportion of states, 10 to 12%, were assigned to the red low activity profile. Now, oh, and then the remaining were kind of split, 50-50. Now, the big idea here is what can we take away from all of these numbers I've just thrown at you? Well, remember that the impetus for this research was understanding the potential challenges and opportunities for making impactful use of the IIJA funding. If we look at the ratio of green states to red states, about 4 to 1, it's arguable that this kind of represents both a challenge and an opportunity, because arguably the red states would be on better grounding to participate in some of the competitive grant funding that's part of IIJA if the states they were competing with were also at that same level. In that sense, the large proportion of green states with strong administrative structures, strategies and execution, they're kind of a challenge to the red states and to a lesser extent, the purple and blue states. But the opportunity here is that because there's such a large amount of green states, this indicates that perhaps, we can leverage the knowledge of these states to create a sort of best practices, lessons learned playbook for the red states and the states with lesser governance capacities to help them as they try to make the best use of IIJA funding. And this would actually be our recommendation to the community, kind of leverage that green state to red state ratio. And then finally, when it comes to Next G and beyond, we'll note, again, with our segmentations, we found that between the red and purple states, so the purple states were the ones with the low strategic activity, they kind of for about a third of the states across our models, which, this low strategic activity is perhaps the aspect of broadband delivery that we focused on that has the biggest implications for preparing for Next G networks. If this funding, the Infrastructure Investment and Jobs Act, is truly once in a generation, this puts a big burden on the states to make wise and especially strategic and forward-looking investments. So strong strategic planning is a dimension that's important in a state broadband delivery program. And we do see that about a third of the states have been identified by our algorithms to not have this dimension. So our recommendation here would be, again, to lean on the larger proportion of states, that are in that green area or even the blue that have higher amounts of strategic activity, but also to lean on the larger stakeholder community here and for that community to be proactive in the sense of helping making sure these states are able to sort of make the investments that prime us for Next G. And that is, the conclusion of my talk. Again, I apologize I moved so quickly, but I will be available in the chat for any questions.